So let's begin with today's work. Today we're going to look at strategy for integration. Now you need to be very careful when you approach section 7.5 because this is one of the most important sections that you're going to have. This section will give you a good advice and it will give you strategy on how to approach your integration question. So let's look at those strategies. Now the first one, this is simplify the integral if possible. Now, if I give you an integral, please try and simplify before you start integrating. Simplify as much as possible. Don't be quick to try and solve them. Sometimes just by simplifying, it becomes very easy to integrate. Look at the first one. You just have root of x times 1 plus root of x. Obviously, just multiply out, and then you notice it's just the power rule of integral. All right, it's straightforward and easy. Also, if you see stuff like this, if you have tan divided by sec squared, go back to the definition of tan and sec in terms of sine and cos. See what happens. Tan is just sine over cos. And you know 1 over sec squared is just saying that 1 over cos squared, which is just cos squared. And if you multiply, see what you get. And if you think even further, notice it, this looks like that double angle identity. So it's just sine 2 theta, half of sine 2 theta. All right. And once you get it to this form, it becomes easy to integrate. Another student might choose to stop here. It's still easy to integrate because it's just a U substitution. All right. But if you can think of this double angle identity, then it just becomes straightforward. You can just get your answer without even doing a U substitution. So simplify as much as possible. Look at this one. Now, if you notice it, there's a square there. So that tells you that you need to square it out, obviously. See what happens when you square it out. Sine squared plus cos squared, you see there's 1. And then 2 sine x cos x, you know what that is. We've already seen stuff like that. It's just a double angle identity here. All right. So please simplify as much as possible before you start integrating. That's the trick. Section 2 or the second strategy say looks for an obvious substitution. All right. Once I give you an integral, the first thing you need to think of, the very first thing we did after we introduced fundamentals of calculus part 2 was a U substitution. So think of U substitution before you start moving to other steps like by parts. Is this a trigonometric integral? Is this a trig substitution? So you need to think of a U substitution first. Obviously, if I look at this, if I differentiate this bottom piece here, I get 2x. And there's an x here at the top, which is going to cancel with that derivative. Therefore, U substitution works. All right. And then if 1 and 2 is, you've checked for 1 and 2, the next thing now is for you to classify in terms of its form. All right. So we start with a trig function. How would you know if you need to do trigonometry integral? Obviously, if you see a product of sine and cos, we've seen that before, where we check the powers of sine and cos, which one has the odd power, which one the even power, and so on. And if you see a product of tan and sec, or if you see stuff like cot and cosec, you know you're dealing with section 7.2. All right. Rational function. All right. So if you have a rational function, you're dealing with 7.4. Remember what 7.4 was? Where we did partial fraction, we did long division, and so on. All right. So remember, a rational function is just defined as a polynomial divided by a polynomial. All right. And now obviously, if you have integration by parts, let's go down a little bit. So if you have integration by parts, where is that necessary? If you see the product of a polynomial and a trig, or an exponential or log function, then you know that it's integration by parts. All right. So in simple terms, integration by parts applied where there's one, you have a product of two functions, where one of the functions you can easily differentiate and the other you can easily integrate, right? And the one that you can differentiate, most of the time it gets simpler, all right, when you differentiate. So you need to think of that as well. And then another one is radicals, right? So if you see stuff like this, plus or minus x squared plus or minus a squared, you know it's trig substitution. Very important, there must be a root. So watch out for your root before you do a trig substitution. If there's no root, it's not trig substitution. All right. And then remember that last example we did where we looked at trig substitution, we did something called rationalizing substitution. So think about that as well, where we let u to be the root of some function. All right. So think about rationalizing substitution as well. And then they say try again. So if everything we've discussed so far doesn't work, just think of something. Try some sort of substitution. Yeah, they say even when no substitution is obvious, you're going to see some examples, they're just unique, all right? Everything we've done so far simply doesn't apply there. You need to think a little bit. So we say you need some sort of inspiration or ingenuity, right? I'm going to show you a typical example where this is going to be the case, where every method we've tried so far doesn't directly apply. You need to tweak the question a little bit or manipulate it a little bit, then you now see a possible substitution. All right, try by parts. They say although it is used mostly for products, so by parts most of the time is a product of two functions, but it can also apply sometimes with single function. We've seen that. When I give you integral of maybe sine inverse of x, you know it's by part. If I give integral of ln of x, although they're single function, you can still solve them using integration by part. All right. All right, someone is asking me if I have audio. Yeah, I'm sure I do have audio. Can anyone not hear me? All right, before we continue, can you indicate if you can hear me? Because as far as I'm concerned, my audio is on. All right, so people can hear me, that's good. Just make sure you switch on your audio from your side, all right? So if your device is muted, then you will not be able to hear what I'm saying. So make sure your device is not muted. All right, let's keep going. Now this one, see, is very, very important. All right, manipulate the integral. Sometimes I'll give you an integral, and like I said before, especially just before the guy complained with not hearing anything, I said the integral, everything we've done so far does not work directly. For example, look at this integral here. You can do a u sub, you can do by part, you can do trig substitution. There's nothing you can do basically, all right? Nothing works. So the trick here is if you see stuff like this, then try and rationalize, all right? Rationalize the denominator. So it means if you see 1 minus cos, just multiply top bottom by 1 plus cos. Keep in mind that you haven't changed the original equation because this thing can cancel out at any time, all right? And if you do that, see what happens. If you simplify further and you split the denominator, you end up with cosec squared. And this one is just cosec times cot. And we know the integral of cosec squared straightforward. And we also know the integral of cosec times cot. So you see, it becomes easy. So think of rationalizing as well. We're going to do some key examples that are going to target we're going to see how to apply the steps. All right, I see someone is asking why is everyone typing the details. Clearly, this is the first time the student is attending. And I hope to be seeing you on a regular basis because you've lost a lot of marks already by missing classes. Your classmate can tell you why attendance is very critical. So whenever you join my session, you key in your details, and that is how I'm going to know if you were there or not. I have an Excel file where I capture attendance, and every attendance, like I said, will count at the end. And if you miss more than 20% of lectures, you simply don't write my exam. It's as easy as that. All right, let's do Let's do example 1. So example 1, there I introduced two different methods. So I'll just go over it quickly. I give you integral of tan cube over cos cube, right? If you notice it, a direct use substitution does not work. So the idea is to try and apply the rules that you know. So one student, this is method 1, one student will say 1 over cos is sec. So this becomes sec cube times tan cube. And now your trigonometric integral now applies, where we say you check the power of sec if it is odd, right? If the power of sec there is odd, you know you can keep a sec and a tan. You see here we keep a sec and a tan, and I'll be left with sec squared and tan squared. I can convert this tan squared using the identity to sec squared minus 1, and then use substitution now works. All right, so just go back to trigonometric integral. And if you solve it, you just get something that looks like that. Method 2, another student will choose to say tan is sine over cos. So they will say tan cube becomes sine cube over cos cube. And then they will simplify as much as possible. As usual, if you end up with, for example, sine having an odd power, if you look at it from this step already, sine has an odd power. It goes back to trigonometry integral. I would say you keep one sine, and then you'll be left with sine squared. You convert sine squared using the identity to cos, so it becomes 1 minus cos squared. And then from here, you just use the u substitution. U equals to cos y, because the derivative of cos is minus sine, and there is a sign that you kept here. It's going to cancel with that du. All right, so it's just a u substitution. Notice it, you end up with the same answers. All right, you end up with exactly the same answers. Now let's look at example 2. Example 2, I ask you for the integral e to the power root of x. Now you need to be careful. This is not just e to the power x. This is e to the power root of x. So don't just tell me that the answer is just e to the power root of x. That is not true, right? You let u to be root. Remember what we said about rationalizing substitution? When you see a root, you let u to be that root, right? In this case. If you let u to be this, if you differentiate, you have 1 over 2 with x. But take note, if I square both sides, you have u squared is equal to x. If you differentiate implicitly, all right, you have 2u du is equal to dx, and you're good to go, because where you see dx here at the top, you're going to put 2u du, and then you just have e to the power with x, which is just e to the power u. So see what you end up with. And you know already, if you see stuff like this, it's just integration by parts. All right. But since we've converted it to u, so we're going to use a t and a b prime. So you let t to be u, b prime to be e to the power u. Remember, you apply layer-T. All right. So you guys know already what layer-T stands for. So we looked at this when we did integration by parts. So apply your layer-T, choose what your t and your v prime will be, or any, you can use any other variable. I just use t since we've already used u in the place of the u substitution. And if you apply by parts, so up to this step, very important, put plus c, because it's an indefinite integral. There's no bounds, so you need to put plus c. The function originally is in terms of x as my variable, so it means that you need to do the substitution back. So where you see u, put root of x and simplify as much as possible. Straightforward and easy. So what's the lesson here? If you try doing by parts from the start, so once you see this question, you try doing by part, notice it doesn't work, all right? It doesn't help you in any way. So the next thing is think about, you see root of x, think about rationalizing substitution. Means let u to be root of x, square both sides, and then differentiate implicitly. And that substitution is going to work, all right? All right, so I'm just checking the comment here. Someone say if we were to write sec as 1 over cos, will we lose marks? Well, you're not going to lose marks, all right? Let's say that you solve this question and then you choose to convert all your sec to 1 over cos. It's fine. It's exactly the same thing, all right? Um, you you don't lose any marks at all, all right? Someone still has a problem with no sound. I'm not sure why you don't have the sound. I'll record the session for those that don't have any sound and they'll watch it later. All right. This session is being recorded, so the video will be made available and you will get the sound. Like I said, unmute yourself because clearly your device is muted. That's why you can hear me. Now, example 3, let's look at it quickly. If you notice, it's a rational function. We know the first thing that comes to mind is section 7.4, but now you need to check the power of the top and the bottom. So this is 5 and this is 3. So before I start thinking of partial fraction, my first step has to be long division. Very important. Why? Because the power of the polynomial, the numerator, is greater than or equals to the degree the polynomial, the denominator, right? So always check the degree. If they're the same or the one at the top is bigger, your first step has to be long division. All right. Let's go to the solution. Sorry, the solution is down. All right, so you see, I'm just doing long division. Please practice your long division so that if you get a long division question, you wouldn't struggle. When you do a long division, always write your answer in this form. So you need your quotient, which is just what you have there on top, plus your remainder. So you see that this is the remainder over the divisor. All right. So whenever I do long division, write it in this form. And just as long division, for example, it counts a lot of marks. So if you write it in this form, then I assume that you know what you're doing. And from this step, obviously, you proceed with factorizing and then trying to apply a partial fraction. So just go down. All right. So let's see. You see there that we just trying to. So you factorize the bottom piece, factorize even further. Notice it at this point, the degree of the polynomial at the top is 2 and at the bottom is 3, means you're good to go. You're good to apply your partial fraction. And these are just linear factors. So this should be the easiest one in the world, all right? So you just apply different constants A, B, and C to each factor. You know the process already by now. You multiply both sides using this whole thing here at the bottom. And then, like I said, you can expand the right-hand side and compare the coefficient of x squared, compare the coefficient of x on both sides to have those 3 equations and solve for the constant. Or another student will choose to let x, so to equate this bottom piece here, this whole thing here to be 0, you have x is 0, x is minus 2, or x is 5. So if you say let x be 0, that is going to give you one of the constants. If you let x to be minus 2, that will help you solve for the second constant. If you let x to be 5, that will help you solve for the next constant. All right. So you can do that method, or you can expand and compare the coefficient. Use the method that works for you, but make sure that you have the correct values. All right. And once you do that, then the next step, you just need to integrate both sides. So I just need to integrate. So the integral of this whole thing here will just be the integral of this piece here. The first part is just power of integration. And then obviously the linear functions, you just end up with ln absolute value, ln absolute value, ln absolute value plus c. All right. If you notice in my other examples, I group the lns together. In this case, you can't group them easily together because look, the coefficients in front of the ln, they're not that cool. All right. And the linear functions are different. So just leave it like this and you get your full marks. So That is the whole idea where you see a rational function. So think about, check the powers, see if you need to do long division or do I need to go straight into partial fractions. So you need to make those decisions wisely. Then let's see, before I talk of homework exercise, I think there was one example that we skip. Oh yeah, this one. So example 4, you can see it's a very short one actually. Now, even though there is a root, so why I put this example 4, because some of you in the other example I did where we integrated e to the power root of x, I say once you see root, you let u to be the root. In this case, you need to be a little clever. You can't just let u to be root of ln x. That doesn't help us, all right? You want it to be, just ln of x, all right? Why do you want it to, why do you want just ln of x? Because you can see there's a 1 over x there. Very, very important. All right. There's a 1 over x, and that is going to be very helpful if you do that. And if you have the right u substitution, it just becomes easy to work with. And there you go. So it's just straightforward and easy. But be careful. Ask yourself, what is in the integral that I can use easily? So I see there's a 1 over x. So the key there's this 1 over x, and it stands for the derivative of ln. Therefore, my u has to be ln of x. Right. I know some of you actually where's 1 over x. The x appears at the bottom. And obviously, if I have to take that function out, it's just 1 over x because the x is at the bottom. And then look at this one. This is another tricky one. So you have root over root. Again, it's a tough one to work with. So you just need to think of rationalizing. All right. So rationalizing means you multiply top bottom by the conjugate of this bottom piece here, the bottom piece. All right. So you're going to multiply top bottom by 1 minus. So instead of plus here, you're going to use minus, and that is why it works. Something like this. Split the integral into 2. This one you know already. This looks like sine inverse. And then this one is just a u substitution. This piece here. All right, easy. Easy as that. So you notice that this section is just like a summary. Just telling us stuff we know again and showing us some extra tricks, all right? And that's basically it, all right? And there's some homework question. Please make sure you do this homework exercise because this section usually introduces some tough questions where you need to think a little bit. So for my side, that is it. Is there any question from your side?